Welcome to Common Core Algebra II. Today's lesson is 6.6, the zero product law. Now, this is something that is introduced to you in Algebra 1 and should not be new to you. All right, and basically it says if the product of multiple factors is equal to 0, then at least one of those factors must be equal to 0. Well, that makes sense, right? So if I said something like 6x equals 0, well, you know 6 isn't 0, so you know x has to be 0, because we know the product of any two numbers that equals 0, one of them has to be 0. So in exercise 1, this is simply what we did very easily in Algebra 1, is if you have x plus 7, I'm right here at exercise A, if you have x plus 7 and x minus 3 is equal to 0, you know that either x plus 7 has to equal 0, or it can be and or x minus 3 equals 0. So in order to solve this, very simply, just subtract 7 from both sides, and x is equal to negative 7, and then you have x minus 3 equals 0. In this case, we add 3 to both sides, and we have x is equal to 3. So hopefully you're recognizing that our factors, here are our factors, and our solutions are tied together. They're tied together because they have different signs. If you have a factor of x plus 7, your solution to that is going to be x is equal to negative 7. And the same thing with our x minus 3, our solution is x is equal to 3. So I think very easily you should be able to pause this and do B and C on your own. So hopefully what you got was 2x minus 5 equals 0, and or x minus 4 equals 0. Now here we have to do a little bit more work because we get 2x is equal to positive 5, and then simply divide both sides by 2, and x is equal to 5 over 2. Now you can leave it that way, or you can write it as 2.5. And then we have our other one here where we add 4 to both sides. They cancel here, and x is equal to 4. So in this situation, our solutions are going to be x is equal to 2.5 or x is equal to 4. And the last one here, notice here, and I'm getting ahead of myself a little bit, I have a 4 sitting out front. So can I set 4 equal to 0? No, because 4 is 4. Okay, that's like telling me, can I set you equal to Dave? Well, no, unless your name is Dave, you can't be Dave. So 4 doesn't have to set equal to 0, but we have to take out 3x plus 2, set that equal to 0. And we also have to take out 4x minus 3 and set that equal to 0. So now minus 2, 3x is equal to negative 2, and divide both sides by 3. And x is equal to negative 2/3. Or we add 3 to both sides here. We have 4x is equal to positive 3. Divide both sides by 4, and x turns out to be 3/4. So those are our answers for this particular one right here. All right, so hopefully that was not any issues for you. Again, complete review from Algebra 1. Now, 2, I kind of got ahead of myself with this one. It says in exercise 1C, why does the factor 4 have no effect on the solution set of this equation? Well, like I said, basically 4 has no effect on the solution because 4 cannot be equal to 0. I don't want to spend time writing that down. You can write that down if you want to. In other words, what I'm saying here is if you have 4 times 3x plus 2 times 4x minus 3, we can set this one equal to 0. We can set this one equal to 0, but you cannot set 4 equal to 0. So write it down any way that you're going to remember it. That's not going to be for me, that's going to be for you. Okay? When you're done with that, I'll meet you at exercise 3. Okay, so the zero product law can be used to solve any quadratic equation that's factorable. Okay, so to utilize this technique, the problem solver must first set the equation equal to 0 and then factor the non-zero side. So I just want you to remember that up to this point, we've solved two different types of equations. We've solved linear equations where basically you have something that looks like, 2x plus 1 is equal to 5. And what do we do here? We get just like we did in the other problem, we get the numbers to one side, we isolate the x on the other side, and we solve for x. In this case, with a quadratic equation, which is the second type of equation we learned how to solve, and again, we did this in Algebra 1, basically what we do is we make sure that we're setting our quadratic equal to 0. So on the right-hand side here, we have the negative 2x plus 10. We need to move that over. So we're going to add 2x to this side. And if you want to in the same step, you don't have to. You're going to subtract 10 from both sides. And I line them up with my like terms. So this side cancels to 0. This side over here becomes x squared plus 5x minus 24 is equal to 0. Now at this point, we can factor this. We've just spent an awful lot of time factoring. So hopefully, when you have a leading coefficient that's equal to 1, factoring is usually pretty easy. So we're looking for two numbers that multiply to 24 that subtract to give me 5. So we have x and we have x, and we have positive 8 and minus 3. All right, so that means our loops, negative 3 times positive 8 is negative 24. Negative 8 plus a negative 3 is a positive 5. So we're good here. So now we have this product set equal to 0. So we know that x plus 8 has to equal 0, or x minus 3 has to equal 0. Again, minus 8 from both sides. And x is equal to negative 8. Add 3 to both sides. And x is equal to positive 3. So I'm going to remind you that we can also check that by just substituting those two numbers back into our original equation, or you can use the store function in your calculator in order to see if it is true. All right, so pause the video and why don't you try B on your own and see how you do. All right, so again, you can do this in one step or you can do it in multiple steps. So minus x squared minus 3x and plus 2. Minus x squared minus 3x and plus 2. So if I did it properly, this should all cancel out to 0. And this side will be 2x squared plus 9x minus 5 is equal to 0. Now, factoring with a leading coefficient of 2 is a little trickier, but considering we just have 2x and x, and then 5 is only going to be 5 and 1, so figuring out where you're going to put that 1 and 5 is the trickiest part here. But it turns out to be looking like this. You can use the box method if that's what's happy. That makes you happy. Now in this case, I'm looking, that's not right, because I need this to be a positive 9. So this has to be positive, and this has to be negative. I can't erase it, so I'll just go like this. This has to be negative. So I have a positive, oh, because it is a minus 9x. No, it's a positive. No, I'm okay. Right, so that's positive 9x. That looks better. So keep going from here. And now I have 2x minus 1 equals 0. And I have x plus 5 is equal to 0. So I know I add 1. I know it's kind of silly to do this all the way through, but you do need to show the math all the way through. 1/2, and here, minus 5, and x is equal to negative 5. So write down what you need to and meet me at exercise 4. All right, so consider the system of equations shown below consisting of a parabola and a line. Find the intersection points of these two curves algebraically. Well, if we take a look at this, we can see how we have y is equal here and y is equal here. So if we know y is equal to two different values, we know those values have to be equal to one another. So when we're done with this, you'll see how it's very similar to the problems that we just finished in exercise 3. So we're going to do the same thing. We're going to move these over, and we're going to these cancel to 0. This cancels to 0, and I get 3x squared minus 12x is equal to 0. And now GCF it, so look for that GCF, factor out a 3x, and I'm left with x minus 4 is equal to 0. Now, this is a little different than having that 4 out front like we did in exercise 1. We can actually say 3x can possibly equal 0, or x minus 4 is equal to 0. So divide both sides by 3, and x can be 0, or add 4 to both sides, and x is equal to 4. Okay? So now, those are my x's. That tells to solve for the intersection points. So I know that my x and my two x's are going to be 0 and 4. So in other words, what I'm saying here is I have 2 points. I have 0 comma something, and I have 4 comma something. So how are we going to find those y values? Well, we're going to do that by picking one of these and plugging in for our x's. So I'm going to use the easier one, which is this one right here. And when I plug 0 in, I get 4 times 0 plus 5, which is 5. And then I'm going to plug my 4 in and get 4 times 4 is 16, and 16 plus 5 is 21. So there are my 2 points of intersection. All right, if you plugged it into the quadratic, you should come out with the same answer. So it says here now to, using your calculator, sketch a graph of the system on the axis to the right. Be sure to label the curves with the equation, the intersection points, and the window. So I'm not going to open the calculator right now because you don't have access to that at home anyway. So I know that my 2 intersection points have y values of 5 and 21. So I have to be able to get 5, 10, 15, 20, 25. I have to be able to get up to 21 at least, 10, 15, 20, 25, and you can simply just go like 1, 2, 3, 4, 5 down here, right? As long as you make sure you are labeling your axes, you can change the scales on them. So we know that 0, 5 is one intersection point, so that's right here. We know the other intersection point is 421. So 421 would probably be right around here. Now, using my calculator, I'd be able to look and see kind of where my x-intercepts are. And actually, I think they come out to be something like this. So I think this parabola is going to look something like, and again, you're sketching it, something like that. Okay? And it said verify your answers by looking at the intersect. So I'm going to remind you that when you look at the intersect command on your calculator, that's when you get those dots. And all you have to do is make sure that the point of intersection of those 2 lines, by the way, those 2 functions, I didn't actually write the other one out, should look something like that. So just make sure that point is there, and then it should come up as that point. In other words, somewhere here, it should say 4, 21. We can spend some time doing that in class tomorrow if you have any questions. Okay, so quickly taking a look at exercise 5. So, and it says here, the zero product law is extremely important in finding the zeros or the x-intercepts, because what happens, we say it all the time, when we're looking for the x-intercepts, in this case the solutions, we know that y has to equal 0. Well, when y equals 0, you have 0 equals x squared minus 2x minus 3, and that's what we've been doing all along, using that zero product law. So it says write the coordinates of the two x-intercepts of the graph. Now in this case, we don't even need to do the factoring because we have our graph here. And it's pretty easy to see that our two solutions or zeros here are -1. So it says write the coordinates. So it actually wants -1 comma 0, and the other one is going to be 3 comma 0. Because remember, when you're looking for the x-intercepts, y must be 0. Now, the next part says find them algebraically. So we actually could work our way backwards here. If by chance you didn't know how to factor this, we could work it backwards because we know the answers are x is equal to -1 and +3. So at that point, if those are our answers, we know that our factors have to be x plus 1 and x minus 3. Well, is that factored properly? -3 times +1 is -3, and -3 plus a +1 is -2. So yes, this is correct. But if you do this, please make sure that you're showing this work. X plus 1 equals 0, minus 1 both sides. X is -1. X minus 3 equals 0. Add 3 to both sides. X is equal to 3. So, like I said, you can actually find your answer sometimes using your calculator, and then just make sure that if it says to do it algebraically, you're backing your way in and checking your work. Okay, so on number 6, algebraically find the set of x-intercepts for each of the parabolas below. So here we are in exercise 6, which is the last one of our set here. So why don't you pause the video, and I'm just going to put the solutions up here that you can check your work with, okay? Don't cheat, really, do the work. Here is the solution to A. Next, here is the solution to B. And lastly, here is the solution to C. So hopefully you're understanding this. Again, the only thing that's a little bit different than Algebra 1 is sometimes we have a little bit more complicated equations to factor, like B with the leading coefficient of 3. But other than that, this is not difficult. It's not hard to understand. So we're going to do 6.6 classwork in our next class. And you should be able to do that pretty easily. So until then, as always, make good choices, be safe, because remember, I care about you. And that's not a line either. You guys know that I do care about you. All right, see you next time. Bye.